name is Katarina, and we are learning the gas laws of chemistry. L for laws. Anyway, we are learning two laws today. We are learning the Boyle's law and the Charles law. Now, the history behind these two laws are that first we start off with the Boyle's law, which was discovered by Robert Boyle in 1662. Now, Boyle discovered that a gas's volume is inversely proportional with pressure. But about a century later, in 1780, Jacques Charles discovered that a gas's volume is directly proportional with Kelvin temperature. Now the thing is, he wasn't the one who published the law itself. Lusac published the law first, but he named it after Charles. What a cool guy. Anyway, let's go to the Boyle's law. Now, for Boyle's law, the temperature is held constant and the pressure and volume are inversely proportional with one another. So the equation for Boyle's law is P1 times V1 equals P2 times V2. And now we move on to Charles' law. Charles' law says that the pressure is held constant and that the volume and temperature are directly proportional to one another. So that means that V1 over T1 equals V2 over T2. Now you're probably wondering, these are just gas laws that I do not need to remember, and I'm probably going to never use them for the rest of my life. But you are wrong, because after you learn these gas laws, you learn the ideal gas law. And the ideal gas law is derived from the Boyle's law and the Charles law. The gas laws are also used for helping scientists in finding pressure, volume, temperature, etc. when it comes to matters of gas. Now, I'm going to show you one example of the Boyle's law and the Charles law. First, you should definitely look at the problem and write out what you have and just solve for what you don't have. Now, for Boyle's law, we have 0.8 atmospheres of HCl at 330 Kelvin and 12 liters is transferred to a 2-liter bottle. What is the new pressure? So, we have P1, which is 0.8 atmospheres. Then we have V1, which is 12 liters. P2, that's our unknown, which we're finding. And V2 is 2 liters. So the first thing is we get our equation and we try to rearrange it so that we have what we need, what's the unknown on one side and what are the knowns on the other side. So since P2 is the unknown, we have to get P2 on one side and the other variables on the other side. So we have P1 V1 equals P2 V2. We divide by V2 because we want P2 by itself, which we accomplish right here. Now it's for the easy part. Now that we've done that, we just plug in the numbers. So P1, 0.8 atmospheres, times V1, 12 liters, and divide that by V2, which is 2 liters. And then we cancel out our liters so that we only have atmospheres, which we want. Okay, now we plug it into our calculator. 0.8 times 12 divided by 2, and we get P2 is equal to 4.8 atmospheres. And now we move on to Charles' law. Now for Charles' law, since it has to do with temperature, we have to always have the temperature in Kelvin. So if the temperature was given in Celsius, you would have to add the number 273 to make it in Kelvin temperature. A gas is collected and found to fill 4.73 liters at 35 degrees Celsius. What will be its volume at STP? Now, you're probably freaking out because it says STP, but don't worry. STP would mean that the pressure would be 1 atmosphere and the temperature would be 273 Kelvin. But since we don't need to use pressure in this, gas law because pressure is held constant. We only need the temperature. So the temperature would be 273 Kelvin. So we have V1, which is 4.73 liters. We have our T1, which is 35 degrees Celsius. But remember, we have to keep it in Kelvin. So we had 273, which would be 308 Kelvin. Now we are solving for V2, so that is our unknown in STP. So our T2 is 273 Kelvin. Now we have to rearrange this equation so that we have V2 on one side and the other variables on the other side. Now we can rearrange this equation so it can look like this and just divide it like we did with Boyle's law. So we divide by T1 to get our V2 on one side. So V2 is equal to V1 times T2 over T1. So now we just plug in the numbers. V1, 4.73 liters. T2, 273 Kelvin. Divided by T1, which is 308 Kelvin. Now we cross out Kelvin, so we are left with liters, which we want, and now all we do is plug it into our calculator. 273 divided by 308, and we get V2 is equal to 4.19 liters. And that is how you do the gas laws of chemistry. Well, two of them, Boyle's and Charles.